So I'm the CTO of Wrangle.io. Wrangle.io, we are a development shop in Toronto focusing on HTML5 applications. And so I want to talk, a lot of it is coming from our experience, striving for continuous delivery in a context of a particularly predominantly front-end work, though a lot of it is also full stack, and also working with clients, which sometimes adds a few extra challenges. So let's start with talking about what is continuous delivery. Now, when talking about continuous delivery, there's kind of a few different terms that are similar, and I think it may be worth just to get this out of the way early to talk about what is the difference between continuous this versus continuous that. So the one term that you probably have heard is continuous integration. Now, continuous integration really means that you are building, that you put your code together early. Now, the other one is continuous delivery, and this is what I'm going to talk about mostly. And then finally, the last item is continuous deployment. Again, continuous deployment, I'm not going to talk about quite as much, though there's, of course, quite a bit of a relationship between them. So now let's talk about, so I want to say a couple of words about each one of them, and then we'll dive into continuous delivery. Now, when it comes to continuous integration, really the idea there is that you want to build your code multiple times per day or after every merge. This is something that is, in a way, a separate topic. I'm not going to talk too much about it. This is, I would say, in many ways, a prerequisite for everything else. I mean, if you are not doing continuous integration of any sort, then probably you shouldn't be spending your time listening to me here, and you should be going back and actually setting up continuous integration. Now, once you have continuous integration, though, you want to start thinking about some of those other things. Now, usually, what you would do in a traditional environment, this is building, like you actually compiling your Java or your C code. In the modern JavaScript front-end HTML5 applications, the build part usually is not that complicated, though increasingly as we're switching to ES6, there's a little bit more of a heavy build step. But what you would also want to, in addition to just the build, you would also want to be running your unit test, linting, beautifications, and all of this ensures that the state of your code is clean, right? And that it doesn't actually, now you would link it together with tools such as Gulp, and there are many solutions for running it. We at Wrangle.io really like Circle CI. That's what we use for most of our projects. Now, this is about all I'm going to say about continuous integration. Again, the important thing there is that this is an earlier step, is something that you want to take care of probably first. It's a bit of a prerequisite. And again, why do you want to do this? It's to keep your master clean and working. Now, continuous delivery is a different thing. It's like continuous integration really means that after every merge, you have code that sort of works in the sense that it's not broken. It's not in an awful state where other people cannot be actually continuing to work on it. Continuous delivery is a little different. It's the idea here is that now you actually want to be producing something of value at frequent intervals. Like you want to make sure that every time you actually got something done, there's value in it. Now, this value, I'm putting an asterisk there because we'll talk a little bit about what does value really mean. And this is kind of comes to the heart of it. Now, and you want, as part of your continuous delivery, your goal is to keep your master not just clean, but actually deployable, right? So you want to be able to say that at any point you could actually take the head of your master and say, we can deploy this and give it to people, and it's going to be A, usable, and B, it's actually going to be better than whatever it is that they got before, at least in some marginal way. And this is, again, going to be the bulk of my talk, so we'll talk a lot more about it. Now, finally, continuous deployment. Continuous deployment is actually deploying that deployable code. Again, so continuous delivery basically means ensuring that your code at frequent intervals is deployable. Continuous deployment is the actual task of making sure that you actually can deploy it. Now, this can be fairly tricky on the back end, but it's relatively easy for the front end. And because of that, oftentimes, I think a lot of the continuous delivery and continuous deployment discussion kind of ends up focusing quite a bit on the back-end needs where things get quite tricky. And consequently, the discussion ends up being often a bit more technically heavy as opposed to really, on the front end, you really need to figure out more the process and the culture around it. And this is what I'm going to, as a result, I'm not going to talk about a lot today about the technical solutions. I'm going to focus more on your process and kind of the cultural norms you want to build around it. So to recap this this is roughly the way I see relationship between those. Now, continuous integration is really a prerequisite. You shouldn't be really launching into continuous delivery, continuous deployment without having taken care of continuous integration, because really no one has an excuse today to be building software without continuous integration. Now, between continuous delivery and continuous deployment, there is actually a bit more complicated relationship. There is a certain sense in which, on the first glance, you would think that continuous delivery is in sort of the next step, and continuous deployment is the last step, right? It's the first you actually make sure that you're producing something deployable, and then you actually automating the deployment. Now, in reality, though, what I'll talk a bit about the fact that, well, it's really hard to actually ensuring that's getting to continuous delivery if you don't have at least parts of the continuous deployment set up. And so the relationship there is a little bit more two-way. Now, other thing I want to talk briefly about is the relationship between continuous delivery on one hand and Scrum, or more generally Agile. A lot of the things that I will talk about today, you can think of that as really a slice of our larger Scrum process. Now, we have found that, I mean, there's really a large overlap between Agile norms and Agile and Scrum process in particular, and the goals of continuous delivery. And in many ways, though, at the same time, what we find is that often it's a lot easier for developers to really wrap their heads around continuous delivery than to wrap their heads around Scrum, which kind of seems this like foreign thing out of project management, as opposed to continuous delivery is something that's a little bit closer to your technical needs. So with that introduction in mind, now let's talk about why should you do continuous delivery. So at Triangle, one thing that we've been trying to do is outline, so we've looked at the different things that we do, and we've tried to extract from them some high-level objectives in terms of to explain to ourselves our own delivery process. Basically saying, what is it that, like, why do we do test-driven development? Why do we do this? Why do we do continuous delivery? Let's kind of ask ourselves, what is the higher-level objectives that we have what we're trying to achieve here. And I will share with you two of our principles here, both of which really affects our commitment to continuous delivery. So one of those principles is the idea of building what is actually needed. Now, seems like maybe a kind of simple idea, almost trivial, but I mean, the number one way to really waste your time in software development, this is the number one way that time is actually wasted, is building stuff that doesn't need to be built, right? I mean, like, everyone had that experience, right? You're working on something for 6 months, or maybe, if you're not lucky, maybe for multiple years, and at the end of the day, this is delivered, and then everyone's kind of like, nah, we don't really need this. And then it doesn't get launched, it doesn't bring any value, right? So this is the single biggest source of waste, is building stuff that is not needed. So we want to look for ways to actually avoid this. Now, the second principle is avoiding work in progress. Now, avoiding work in progress is a little bit less intuitive, and this is an idea that comes out of lean manufacturing principles, kind of the Toyota production system. And the idea there is that whenever you have something that is half done in a sense that you can't, like, you've sort of started working on it, but you haven't gotten far enough that you can actually extract value from it, then it's a waste. Right? It's a waste because if you have this comes out of the Toyota production system, where the idea was that, well, if you've built half a car, and now you've basically got a warehouse that have a whole bunch of half finished cars, this is dead weight on your process, because those cars, no one is driving them, no one is paying you money for them, they're just sitting there, right? Now, in contrast, if you reorient your process so that you start working on a car, you finish it, and you ship it off, and it gets sold to someone, now someone is driving it, you avoid work in progress. So those are kind of two principles, both of which, among other things, suggest the need for continuous delivery. Now, it's important to note this with the second principle, part of it is it has its own value from the perspective of reducing waste. But it also closely linked to the first principle, in that whenever you have work in progress, it always means that there is a chance that whenever you are done with that work, it will turn out that you are working on this in vain because it wasn't actually needed. So by basically ensuring more frequent iteration, making sure that you deliver something early, you get feedback on it, and you actually know that you didn't waste your time, and also you don't have, and also you can actually speed up the process where people can actually start using it sooner rather than later. Now, another idea that we have engaged with quite heavily at Wrangle is the idea of lean startup. And with lean startup, this actually kind of comes with a little bit of a challenge to, it brings a little bit of a challenge to sort of kind of traditional notions of Scrum and Agile. And the way we've tried to reconcile, in the sense that there is often really an emphasis on lean manufacturing and saying that, well, you really want to say, like, what's the absolute least that you could do, right? And to learn what you want to learn, right? Which is a little different from asking what's the least that you could do to actually deliver value to your users, right? So there's a delivering value to your users versus wanting to learn so that you could actually pivot and perhaps abandon that user base altogether and switch to serving needs of someone else. So the way we've tried to unify this is under this sort of principle of delivering early for value and or learning, right? So you kind of want to think about this, right? So you, in both Lean Startup and Scrum, you ultimately are going for this early delivery. What is it that you're delivering for may be a little different. In some circumstances, you would want to go with a sort of classic Scrum, where you are, what you want to deliver is you want to deliver tangible value to the users. You want to get this into your users' hands so they could start using it and extracting value out of it. Now, with in some cases, you would want to actually lean towards sort of learning, which is kind of a bit more of a lean startup, where you say, well, no, what we want to do is we want to deliver something that is really more of an experiment that we can actually learn from. But again, in either case, you would want to actually deliver those things soon, and so that you could either your users could start enjoying the value sooner, or that you could learn what you need to learn sooner. And in practice, of course, your path may kind of end up, maybe first you lean towards one early in the project because you really have a lot of assumptions that you want to clarify, and then maybe later down the line you actually shift towards delivering tangible value. So this is the motivation for why you want to do continuous delivery. And now let me talk about how do you actually get to it. And I will focus on two items. One is having good user stories. So user stories is a tool that we use quite a bit in our own project planning. And the idea there is that everything you work on, you ultimately organize it in the form of a story that, or a statement that about the value that this is going to present to your users, right? And now this is not a Scrum-specific idea. You can use it with other Agile methodologies, and a typical classic user story looks like this. So you usually say, as a user, I want ... so that ... Now, this is something that I think that the idea of user story is probably something that most people have heard of, but I want to kind of point out a few specific tips when it comes to writing better user stories for the purpose of being able to actually deliver value in smaller chunks. Now, one thing is rule that you probably should follow is whenever you're writing user stories, oftentimes people literally start them with this as a user, right? And it's rarely a good idea. You should really just banish the word user from your vocabulary and from your user stories. Now, the reason for this is two. I mean, first of all, it's just really toxic to think of people who use your software as users, because when you think of them as users, it sort of encourages you to think that all they do is use your software. And really, they are people who do different things. And the moment you start actually identifying what kind of people they are, you open your eyes to all of the other concerns they have, and you start realizing that your software is really not at the top of their priority list, and that you need to kind of think about it a little bit more. Now, the second part, though, is that by putting something a little bit more specific than a user, you also open yourself more of a door towards prioritizing features and thinking of whether you actually need to do this or what the more specific solution can be. Now, the second piece is not skipping the so that. So oftentimes there is a kind of perverse form of user stories where people say, well, as a user, I want to log in. And the so that part gets skipped. What this now means is that you effectively have gone and made a decision about what is it that the user wants without having necessarily thought much about the context of what is it that they're trying to achieve. Instead, a better practice often is to really focus on the so that early and to defer the I want part. So your sort of the first draft of your story might look something like as follows, right? When you say, as a parent traveling with a child, I want, and we're going to skip that, the dot, 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 what is it exactly that I want, so that my child can travel with me. Because now that is the context. That is what you actually ultimately want to achieve, right? This now opens ourselves up a lot more opportunity to start thinking of, well, how can we, if this is too much of a chunk of work to really deliver in a small iteration, we can now start thinking, how can we actually size this story down? So let's talk about sizing stories. So one of the methods that we use, and this is common to Scrum, is we actually size stories. We talk about, and we size them in points. Some people size stories in points so that they can actually do forecasts. My take on it is you really cannot use that for forecasts. But what you can make sure is you can actually make sure that you can size stories so that you actually can make sure that they are small enough that you could deliver them within an iteration. Right? Because in order to be practicing continuous delivery, your number one step is you need to make sure that when you start working on something that can actually be realistically finished in a really short period of time. In our case, usually we do 1 week sprints, and we try to break our stories small enough so that they take, on average, a couple of days. Right? So that each developer would potentially be delivering a couple of stories per sprint. Now, and again, so in order to do that, because if you do that, then you can actually make sure that every time you merge, you're delivering some tangible value. But in order to do that, you really need to be aggressive in splitting your stories. So now let's talk a little bit about downsizing stories. Because ultimately, this is usually when you start thinking about what is that you're trying to do, the scope is too big. It's like you look at it and you're like, this is 3 weeks of work. Now, so once you've taken yourself a 3 weeks long chunk of work, then, well, it's going to be really difficult for you to actually practice continuous delivery. You want to split it down. So you want to ask, first of all, what's the smallest solution that's going to bring value? Right? Let's think of like what is the really like in that task of, as a parent, I want something so I can actually travel with my child. What's the smallest, simplest solution that will actually achieve it? Because again, if you start thinking of the long-term 6-month out solution, then you're going to kind of get back into this. I am now got six months of work that I'm going to be working on, and it's not going to get integrated until we've done all of that. Now, one option you could do is you can actually narrow down by user. So once you actually start thinking, instead of thinking of as a user, you start thinking in terms of specific users, you could say, well, there is the needs of people who actually have a infant of under a year, because they perhaps, if you're building, let's say, a sales system for a train, they actually just get to travel for free. They don't really need to do anything, right? So they just need to know that they don't need to buy a ticket. Versus the needs of a parent with a child of 2 to 5 are actually different, right? So once you start splitting the users, you can say, okay, well, within this iteration, let's provide value for the first type of user. Let's provide this very initial information to the users where they know whether they actually need to call, whether they need to get a ticket for their child at all or not, and maybe provide a phone number for them to call if they actually need to get a ticket for their slightly older child, right? So this is the idea where you're basically, instead of setting yourself the really long-term goal, you say, what's the simplest thing we could do that will actually provide some value? And you really want to start thinking about incremental refinement, right? In terms of saying, okay, well, what can we get done today that we can actually launch, and we're going to improve upon it later. Now, the one particular thing that we strongly recommend is avoiding horizontal slicing. Now, with this of stories. So oftentimes people have temptation to basically split the back-end work from the front-end work. Now, the downside of this is that usually when you split your work into back-end and front-end, neither part is useful by itself, right? So your back-end work isn't bringing any value until your front-end work is done, or if you do it in the opposite order, right? So you're now delaying integration. Essentially, you cannot deliver this feature. So what we prefer is to do full stack or quote-unquote vertical stories, where we really say, okay, no, the task is to provide this particular feature all the way down, the front end and the back end. This gets a little bit trickier in more traditional stacks when, let's say, if you have Java developers doing the back end, you have JavaScript developers doing the front end, it gets a little tricky. With the mean stack, it actually makes it quite easier because then you can actually have the same person really working the whole stack, and this is what we often do. Even when we have, let's say, a team with 3 developers, oftentimes instead of saying, well, out of those developers, one is front end to a back end, we'll say, well, oh no, they're all full stack. Each one of them takes a feature and finishes it beginning to end, in which case, within 2 days, you can actually add something tangible that really gives you actual complete value. The other thing that you want is you want clear acceptance criteria in your story, right? So now, one thing is you want to avoid feature creep during an iteration. Right? Oftentimes, what happens is that you actually set this story, and then as you are working on it during the week, the product owner comes back and they're like, oh, we should add also this, we should also add that. And then you've sort of got this feature creep, and the outcome of that is that you're actually not going to be able to do this within this reasonable time. What usually makes more sense is to say, well, no, those extra things that are coming in, we need to actually treat them as further improvements. We're going to do this in the next iteration. And you also want to have a lot of confidence of what you're building, that this is actually going to deliver value. And this is where, again, a clear acceptance criteria really help. You want to know that this is what was agreed upon. You're going to get this done. Within 2 days, you're going to launch it, and then you're going to move on to the next iteration. So this is one, I would say, important thing to get to continuous delivery is really putting the work up front to really define work in small enough chunks. Because I mean, again, if you're working in like 3-month-long tasks, then there's nothing really you can do to deliver continuously. Now, the second big item is not getting stuck on bugs. The reason for this is ultimately, think of it this way: buggy software is work in progress, right? If you cannot launch your software because it has bugs, it means that you're going to keep working on it, and you're not launching it, right, until you've resolved it. So, and you don't really want to have unfinished work. So now it gets a little tricky. So there's a little bit of a contradiction there, because on one hand we're talking about you want to launch early, and on the other hand, so we're saying that, well, also you don't want to have bugs in your software. So how do you reconcile this? Well, the ultimate test is whether you can actually ship it this way, right? So this is an important, like when you think about bugs, you need to think of like there's bugs that are really showstoppers. Like you cannot deploy your software with this bug in it. So now if that bug is something that actually turns your work into work in progress, which means that it's interfering with your continuous delivery. Now, on the other hand, there is maybe things that they are limitations of your software, but they're limitations that you could actually ship without, and those it often makes sense to defer. Now, the other thing that we also kind of have to think about is that bugs in development time are really a fact of life. But at the same time, bugs at the end of the iteration are a problem, and we need to get out of this sort of, I think a lot of teams that kind of have this approach that, well, it's like, I mean, bugs are a fact of life, right? So we wrote a bunch of code this week, and we've got a bunch of bugs, we're gonna fix them at some point later. We try to take an approach that, no, you want to close your iteration with no bugs. I mean, this is to some extent an essence of Scrum also, but and so I'll talk a little bit about how do you do that. And you want to also look at your whole process and look, when it comes to bugs, you need to take the approach of debugging the process, which is to say that if you are finishing your iteration with bugs, you need to stop and say, well, it's not just we have to fix those bugs. We need to fix the process so that we actually minimize the number of bugs. So at Angle, one of the key metrics we use is the number of rejected stories at the end of the iteration. We're talking about week-long iteration, right? So we track and say, okay, we've delivered 5 stories. How many of them got rejected by QA? If one of them got rejected out of 5, okay, maybe that's not so bad. But if 2 of them got rejected out of 5, now we really have, we're not managing to actually close bugs within an iteration. Now, why? The other thing that when it comes to our approach to bugs, and the reason also, deferred bug fixing costs more. This is something that we also always have to keep in mind, right? So in the sense that if you're coding and you see that there's a bug that you've just introduced with something that you changed 2 minutes ago. It's really, really easy for you to fix it. Now, if the same bug gets deployed, it gets, you manage to commit with that bug, right? You didn't notice it. It got committed. It got merged. It got caught by QA 3 days later. QA comes back to you and they're like, oh, you found this bug. Now, 3 days later, it's going to take you a lot longer to fix it because, you're completely in a different context now. So this has an interesting consequences, which is that leaving testing to testers is often actually problematic. Because if you are saying that testers are going to be doing testing after we've done development, you are basically asking for deferred bug fixing. So you effectively end up with a sort of mini waterfall inside of each of your iterations, and it ends up being really, really difficult to actually close your iteration with bug-free code. So what we've been trying to do at Triangle is really focus on truly continuous delivery, where we don't just deliver stuff that's deployable at the end of the iteration, but really where every merge is deployable. So now, if you do this, the question is, how do you approach testing? So this is the the answer ultimately is, the short answer is that testing needs to be everyone's job. It needs to be everyone's job, and first and foremost, it needs to be developers' job. So here's roughly the approach that we use currently. So it's a variation on the GitHub model, but with a bit of extra information about testing baked in. So a developer picks up a story. Now, the story needs to be written with all of those things in mind that I've mentioned, that it needs to be very clear, it needs to be small, and they make a branch, they start working on it. Now, at number 2 here, they've done some work and they think they're done. So they make a request, they make a pull request. The pull request is created. The pull request, the CI run is triggered. Now, the continuous integration part, that, as I said before, this is the prerequisite. If you really don't have continuous integration working, then you really, shouldn't be listening to this. You should be doing continuous integration. Now, let's say that in this case, the continuous integration fails, like some unit tests, fail in continuous integration. So the developer goes back to the drawing board, they rework their pull request, they make a new pull request, and now continuous integration passes. Now, at the end of the continuous integration, what we do is we create something called pull request environments. Now, what this means, and this is the item 6 there, which says PRE, this is pull request environments. Now, the idea there is that you want to actually be able to test your code. Not just, oftentimes people do code reviews on the pull request, right? So someone else looks at your code, but they need to really also be able to verify that it actually works. So the way pull request environments work is you can do them 2 ways. So in case of Heroku, in case of web applications, we currently use Heroku, and Heroku has a nice feature called build environments. The way it works roughly is that you basically hook up Heroku to do it for you, and then it goes and it annotates. So after your CI runs, Heroku will go ahead and actually create an environment for that specific pull request, and it will go and post a message on your GitHub inside of the pull request, where it basically says so-and-so deployed, there is a pull request an hour ago, and then when you click on that deploy, what you get to see is that you will see that the application running as of that pull request. We are now switching to a Docker-based setup, which is, So we're now switching to a Docker-based setup that we're calling the Clusternator, mostly because we've been finding that Heroku is a bit of a hard sell for production for a lot of clients. So there's a lot more interest in running on AWS with Docker in particular. So we're trying right now to reproduce something fairly similar on with Docker. Now, and the main reason for this is because when it comes to continuous deployment, you really want the same environment in development and in staging and production. So in our case, we've been finding it really easy to use Heroku for development, for creating those build environments. But if you're not using Heroku for production, then that becomes a problem, right? So that's why we're kind of going back towards saying, okay, we want a unified approach that's going to work in production, that's also going to make it really easy for us to create environments in development. So we're working with the Clusternator is now our solution to this. Now, it gets a little bit trickier with Cordova Apps, and there we've worked on a solution that we call Cordwood. And Cordwood basically is a container app I don't know if you guys seen this. Like generally, when you're building a hybrid app, one of the advantages of them is that you can actually live update them. Now, so in this case, it's a setup that allows you to live update your app, where every time you run it, it can load the new version, but with an extra twist, which is that whenever you restart the app, instead of going to the latest version, it actually gives you a list. Oh, sorry, it gives you a list of the pull requests. So you can actually then pick the specific pull request, and you can actually the app will load into that pull request. Now, why are we doing this? Well, let's come back to this picture. The idea now here is that after this CI has passed and the pull request environments have been created, someone else on the team is going to review both the code and the actual running application. So they will look at your code and say, yeah, the code looks good, but they also need to go and actually effectively test your application. And then if, let's say, this time they failed, but so you go back to work and you actually rework it, and then this next time they actually review it, and now they give it the ship it squirrel, and now you're ready to deploy. I will skip, there's a few other steps there, which is what we do afterwards. We usually do, in addition to this, we do code reviews that are kind of on a weekly basis between the different teams. And we also have testers often go and do some review occasionally, but after the merge. But the focus here really is that you need to test before you merge. And again, we're moving increasingly towards the setup where most of that work is done by developers, because they're in the best position to actually go and fix things right away. Now, you may wonder at this point now, if we're asking developers to do testing, then what do testers do all day, right? So our answer to this is that, well, first of all, they actually help write better user stories. So in a sense that the kind of tester mentality of terms of like thinking of what can go wrong, we try to have them apply that not after the application got delivered to them, but instead before the story has actually even been dispatched. So the idea is that, like kind of the question of like, well, what will happen if you do this? We have that discussion up front, right? Because then what we can do is we can actually discuss upfront with the product owner of, well, maybe this is okay. Maybe when this enters, we just don't want to support that case, right? Or maybe we do, in which case now perhaps that story turns out is too big, and therefore we need to split it up. And the second thing that our testers do is they coach developers, right? So the idea is that when you're asking developers to do more testing, that's for a lot of developers, that's a new experience. Testers have a lot of more experience on that front, so we ask them to help developers with that. And then finally, the last task that we ask them to undertake is debugging the process. I mean, debugging the process really means taking the approach that if we are catching bugs after merging, then we need to kind of go back and do a bit of an investigation, not as to like what is causing that bug, but how did that bug actually get through, right? And so this is, within Scrum terms, we call it a mini retrospective. So the idea is that you actually want to kind of get together and say, okay, let's talk about this bug. How did it happen? Did you do testing? Maybe, you discovered that, well, what happened is that the developer was testing on iPhone, but they weren't testing on Android. And so maybe the conclusion of this is we need to move to a setup where, a kind of a team agreement where every developer will test on both iPhone and Android before they actually commit or before they merge. So this is kind of what I mean by debugging the process. I want to say a couple of words now about automated end-to-end tests. Now, for a lot of discussion of continuous delivery, this is really an important piece. Oftentimes, there's a lot of stress on automating testing. And indeed, automated end-to-end tests can save you time doing regression testing, and they can increase your confidence. Now, it's important, though, to consider that they do have cost. I mean, they can be really expensive to maintain as your application changes. They also often result in a lot of false positives. So as a result, our approach to it is, you do want to do an automated end-to-end testing, but you don't want that to be the foundation of your testing strategy, because instead what you probably want to think about is you want to consider unit tests. Are you actually squeezing everything you can out of unit tests? And you will also want to think about REST API tests, because in contrast to writing tests that actually hit your backend and tests that you get the right responses just much, much easier than writing end-to-end tests that sort of try to interact with your UI. Now, when we do end-to-end tests, we prefer WebDriver I/O. We do that for all of our testing, even on Angular. And then finally, in our case, we actually mostly have developers writing those tests. Now, the reason is we've experimented with the idea of having testers write them, but it gets trickier because it sort of gets you out of the continuous delivery part, sort of workflow, because if you have one person do the feature and then hand it off to another person to write the tests, it creates this delay, right? So instead, what our approach has been that whoever is writing the feature should be that if your feature breaks your end-to-end test, you should actually fix the end-to-end test right away, and they should form part of the same commit. Now, finally, I want to say just a couple of words about continuous deployment. Now, what I wanted to, the key there is it's actually hard to practice continuous delivery without at least good staging support. Because what I've stressed before, right, is that part of our approach is that you want to make sure that when you are merging your commit, you have access to the actual environment that runs that specific pull request. Because otherwise, how can you possibly have any sort of confidence that it works? So in that sense, you need at least that element of continuous delivery. Now, ideally, you really should be deploying to production using exact same method as you use for deploying to your staging environments. Now, the catch is that there is a bit of an extra twist when it comes to really deploying to production. And the difference between deploying to a staging environment, deploying to production, is that you do need now to support, first of all, rollbacks, and you need to support data migration, right? And in particular, you need to support rollbacks that actually take account of sort of unmigrating your data, right? So this is the main difference. So in a way, you could get by with sort of a light version of continuous delivery, where continuous deployment to support your continuous delivery, where basically you create environments from scratch. You kind of assume that your data is always just thrown away. When you really want to practice continuous deployment to production, you do need to actually figure out the scenario for rollback and data migration, but that's a different talk, so I'm not going to talk about it today. So thank you very much, and we have a few minutes for questions. And the slides are available at the URL over there. It's yto.io/xcd. Like XKCD, but without a K. Yeah?
You mentioned that your solution to having, or for the issue of writing stories that go full stack, your solution is to have a full stack developer.
Yes.
Do you have a recommendation for full stack stories or stories that require multiple areas of specialization when you don't have that staff?
So what we have done in some cases, and that may be, I think, a solution that works for, so there is a kind of a full stack where we basically have, where we do the whole thing, right? And then there is a, one of our developers can really go and fix the front end. They can make a change to the back end. Usually in this case, we're using Node, so JavaScript all through. Now, there are other cases. So the other approaches are, one is you really work very close with the backend team. You really kind of like have a direct line with them. Ideally they sit next to you, in which case you can't really quite do it necessarily have the same person doing it, but at least you're doing it at the same time, right? So you're almost doing kind of a version of pair programming where you're basically saying, okay, well, I need this, can you? And so they say, okay, I'm going to get this done, right? It gets a little bit more complicated because you need to work in a share a branch and do those kind of things. Now, the other approach that we've done in some cases is when the backend team is really removed, we sometimes put an extra proxy layer in front of it that we do in Node. Now, which helps often for other reasons, because like if you have a backend that really is not written with your particular mobile application in mind, it often ends up easier for other reasons to actually have a server that really proxies those requests and that basically translates them into format that makes most sense for your mobile application. Now, and the extra benefit you get with this is that a lot of the problems you now can resolve within that layer. And so again, you're kind of back to the full stack, almost full stack scenario. Other questions? Yeah? Say it again? So okay, so it's, why the reason we do 1 week sprint? So 1 week sprint is actually, as far as Scrum goes, that's really short, right? Like I would say, the typical recommendation for Scrum is 2 weeks. Sometimes some teams do 4 weeks. We do 1 week sprints because our engagements are often really short, right? So if a client engages us for, let's say, an 8-week project, then 4 weeks, that's like 2 sprints, right? That's not really, you don't really do iteration in any meaningful way, right? I mean, if we deliver something to them after 4 weeks, that means we're delivering something halfway through the project. So that's the reason why we do really short sprints. Now, I wouldn't necessarily, if you're working on an internal product, I wouldn't recommend 1 week sprints. You probably want to go a little longer. I would say maybe 2 weeks. Some teams choose 4 weeks. Now, in terms of can you break it down? I mean, what happens if? Yeah, I mean, sometimes you just cannot break it down. It happens, but it's off. In many cases, when it's at first looks like you cannot break it down, there's sort of questions you can ask yourself that actually help you break it down. So yes, I mean, sometimes you won't be able to, but in many cases you will if you think about it creatively enough. And in particular, you would want to think in terms of, can we actually do something that will only serve a subset of the users, that will bring value to a subset of the users, and then also, can we actually provide, part of the value? Other questions? Yeah?
So for the PR environment, you do that externally. Why, I guess the context is for our testing environments, we do the PR environments locally, so whoever's testing it pulls it down to their local environment, they have one they choose to set up, and we do PR environments there. Why would you choose to do it remotely? It seems to be more overhead, my understanding.
Well, I mean, the nice thing with doing it remotely is that, so first of all, I mean, the one, I would say the key principle there is that you want your staging environment to be nearly identical to your deployment environment, right? So if you are saying that you've tested this while running your server on a Mac, right? It means that there is a chance that when you actually deploy to AWS, it's not going to work. Right? So if on the other hand, I've actually deployed it on AWS, so I've done my test on an environment that runs in AWS, and the production environment is identical machine, also in the AWS, then I have a lot more confidence in it. The second thing is that in terms of overhead, I mean, it's overhead when it comes to setting it up initially, but once you actually have it going, it's a lot less work, what we've been finding, right? Because we were for a while doing this sort of step where basically we tell people that, well, when you're reviewing pull requests, you need to go ahead and actually get that pull request down, but that takes at least minutes and possibly longer, as opposed to with the, you take it out of your phone and you, our current setup with Cordova, there's really nothing you need to do, right? Like if I ask you to review my pull request, you don't need to get any of my code, right? You look at it, you go to GitHub, you look at my code in the browser, and then you pull out your phone, you select my pull request, and it runs there, and you can actually click around on it, and you can actually, thus ensure that it works without really having to do anything in terms of setup. Okay, we're at 0 minutes, so I think we're going to have to close here, but I'll stick around in the corridor for anyone who wants to ask questions.